Hello, everyone. And today's session is on an update on the drone and PX4 board we were creating and the entire ecosystem we are creating around the drone interest with 96 boards. And this is just an update. I did a very similar session last Connect. So initially, I'll just go through what we discussed last time, and we have an exciting update. So I'll go with that as well. All right. Just as in recap, we are partnering with PX4 Autopilot to have our flight management unit running their software and their hardware, and we are pairing it with the 96 board CE and SOM spec as the APU tech to do all of the high level stuff, which I'll get into in a bit. And the new board is being designed by Upvoter. They were known as Gumstix, so a lot of you might know by that name. But now, since they've been acquired by Altium, they're actually now Upvoter. So they are helping us manufacture this board. So one of the overviews I want to go into is the purpose why we are doing this. We wanted to expand the 96 boards ecosystem around the drone interest and the drone market. PX4 is a very big player in that area, and we didn't want to reinvent the wheel, so we just ended up partnering with them. We've had an older board called the AeroCore 2, which had a limited run, but we weren't able to create a large enough community. I think we are trying to sort of solve a lot of problems with that board. But this time around, PX4 actually has a SOM called FMU V5X. They have FMU V4. FMU V5X is the newest one on the market, and they're planning with the newer models as well. But we chose to stabilize on the V5X, which is a pre-built SOM. So it's easier for us. We don't have to do a bunch of engineering on IMUs and everything. They have the hardware packaged in SOM, and we can put that up on our either mezzanine or our SOM baseboard, as you'll see further on. The idea with this partnership is to get our application processors on 96 boards, SOM, and and CE form factors to do the real-time 3D mapping, photogrammetry, live terrain point cloud, and all sort of high-performance stuff, while the FMU uh, actually controls the drone, make sure it doesn't go where we don't want it to go, and we also have at the FMU streaming flight data onto the APU to sort of help it with in a lot of terms like mapping and all of that, where you want GPS and positional data to accurately map things out. And so our audience was a bunch of people who are interested in going beyond just flying drones and doing analog video, um, uh, which we usually see in the world of the drone racing community, where they just have an analog link. If people want to go beyond that, they want to do real time compute on the drone. That's sort of the area we're targeting. All right, so I did talk a bit about the PX4 situation. They are an open source software. The Autopilot is the open source software. Their PX4 FMUs are a standard, as well as they have some reference designs for flight management units. So one of them, which we are using again, is the FMU V5X. It's a Cortex M7 and a Cortex M1 based flight management unit. So they do this really nice thing where they use the smaller Cortex core, the STM32F100 based MCU to do the IO management, and the larger M7 based MCU to do the flight control and data acquisition and all of that stuff. So that's what we're using. Um, we wanted to create two boards, the CE mezzanine that would fit on a regular CE form factor board, and a SOM base board where you would have your 96 board SOM and the FMU all sandwiched together with some more peripherals, as a full feature rich onboard compute solution for your drone. and that is something that we've been working on. Here were the earlier mockups that I showed last time as well. This is the mezzanine board is still in the more or less the planning stage. Oops, did not. Yep, there you go. The the mezzanine board is still in the planning stage, whereas the V5X base board or the 96 board SOM base board has been manufactured. And you'd have seen me talk either on Twitter or on other social media platforms about this, but this is sort of the official release or first time I'm showing the board anywhere separate. Um, so here it is. It's yeah, so at the back of the board, and I'll go into much detail, and I'll show you up close how this board looks like. But from this first look, at the top of the board, we have the FMU V5X. That's the black module. We have an M.2 slot for an SSD to have all that 4K footage captured on board, and then we have our 96 board SOM at the bottom. A lot of this is a demo show and tell. So I will have to try and ad lib that. Um, right. So this is the main board. As you can see, we have the FMU V5X SOM. It comes like this in its like heat sinked package, and um, it is connected to the main SOM or the main 96 board SOM over Ethernet, I2C UART. So we just wanted to expand and see what all we can connect it via our SOM, and just to experiment with what's the best case scenario to transfer data between the two. There was also CAN bus involved, but the funny story is that the silicon shortage has hit everyone, unfortunately, the automotive space that uses a lot of CAN bus has been hit pretty hard as well. So we weren't able to get the CAN bus chips for this particular board. There are revisions planned. Actually, one should be arriving this Friday, and yeah, apart from that, we have our SSD, our M.2 NVMe SSD slot that gets connected directly to the SOM, to the 96 board SOM. And I just have a 512 gig install just to capture all that 4K goodness. Apart from that, we have 2S for power. The micro USB port you can see is mostly for debugging. It has a hub and a couple of bridges, USB to UART bridges that go to the PX32, the PX4 V5X, and the SOM itself. There is a USB Type C which acts as a hub, and on the later versions, I think we are powering for debug purposes. We are powering the board as well um, from the Type C port. We have an HDMI that's mostly for debug. It's on that on the edge case you'd want a screen on a drone, like you're doing some advertising or something, and in you want drones flying. But really, it's just for easy debugging, just to see the video outputs are working fine, and things like that. So it's we are not expecting people to fly out with a large TV on there. So I'll talk a bit about the board, but so this is the board booted up, and we'll go into a quick demo. So this is sort of very early software for the SOM itself. So first of all, I'm just showing you the read-write speeds of the NVMe drive. It's not a super high-end NVMe drive, so you're not getting multi-gigabit speeds. Also, I think the link is only X1 or X2 instead of the regular X4 link. So, but it's still good enough. 600 megabytes read and 700 megabytes write, I think, are good enough for something like that. At least basic 4K video streaming and recording on board. So We have a very small demo right now, which I sort of have improvised. So coming on to this setup, this is the same thing, the same board I showed you electrically. It's exactly the same. I have my NVMe drive on a PCIe card over there. It's the exact same NVMe drive. My SOM on the baseboard. This is the test baseboard for 96 board SOM stuff, and my Pix 32 connected over UART to the larger baseboard. Now the reason we are doing that, the board I just showed you is not entirely functional. So we have already, as I said, we have already revised it, and it's on its way. It'll arrive this Friday, so that's all fine. um, and yeah, so it's all electrically the same. What I'm going to show you will represent, actually you don't even have to change the code, it'll just work. um, so I have the telemetry radio because the firmware at that time did not have drivers for the FTDI chip. But it's a UART link, and that's how it acts. So the demo is a very simple Python script. What we are trying to achieve is to get Mavlink data from our FMU over to our APU, and just as a proof of concept, have it overlay on a video screen, on a particular video, and eventually stream that, or record that, or do anything more useful with that um, frame. So right now I've just run the demo, and it's based on FFmpeg, so it's, you know, getting its frame, recording its thing, and I'll quickly, yep, that, close it, and let's try and play it back. Right. So that's the camera feed um, from the 96 board SOM. So the camera is connected through a USB 3 port, and as you can see, as I'm moving the FMU, you can see the heading change a bit. Let me just go back and show that again. As I move the heading change, the heading is a reading from the gyro, the compass, and so I'll go into detail how the headings read. But it's a Mavlink packet, and I'll go into the code in a second, and show how we are decoding that. Luckily for us, you don't have to go and decode the Mavlink packet using the standard Mavlink library, because it gets a bit too involved for my liking. But there's a very good library called DroneKit, and DroneKit basically is a very simple wrapper over Mavlink. Does a lot of setup for you, and just eases everything. So for the DroneKit stuff, we just create a variable called vehicle, connect it over UART. In this case, it can do anything, I2C, UDP. So that's over LAN. That's what we are going to do next. Um, and that should be faster as well. And then you can just call different data types from it. So firmware version, the next line is just a string. It's just the data for, vehicle.version that just gives the FMU firmware version that's currently flashed to it. Um, FFmpeg, I did have to. I'll get into that FFmpeg string a bit later, but let's come down to the while loop. Um, so skip the overlay.txt. Next line, we have the buffer, which is a text or a string buffer, where we call the firmware, the status of the vehicle, whether it's standby or flight mode, the current heading, which you guys saw it changing, and the GPS status, which was showing null because I don't have the GPS connected. Also, I live quite a lot, surrounded by 2.4 gigahertz Wi-Fi and a bunch more other interface. So GPS doesn't really work inside. So yeah, I write text file to a buffer, and then I have FFmpeg continuously reading that buffer one frame at a time and overlaying it. As you can see, I was talking a lot about 4K video, but this one's at 720p. That's because I'm still trying to get mainline Linux and sort of upstream you would working on it, so I can use proper video encoding and decoding using the onboard VPU. And that's important because Rockchip has like 15 different ways of doing it downstream, but upstream kernel stuff just works. So right now, just for the purpose of this demo, I reduced the frame rate. I reduced the video size, so the frame rate would be a bit usable. Um, Sorry, got sidetracked by a message there. Yeah, so that's basically how we are um, using like running the demo, and that's how we intend to move forward with initially just having the drone fly, and just have a single button press, because with the Mavlink you can actually take the any data that the FMU has, that includes throttle and all the other buttons that are on your controller. So you can read that, and you can sort of assign a controller to a custom variable and read that over from DroneKit or Mavlink, and sort of have that button start and stop your recording digitally. Um, so yeah, that was it for the demo. I'll close that out. Okay, how are you getting? There you go. Uh, right. So yeah, that's end of the talk. A few footnotes is that in the coming weeks I will be flying the drone, because as I said, the fixed board is already here. Once our basic demo is ready, I hope to get a mezzanine version working so we can expand our portfolio of SoCs that we support. We just have the Rockchip RK3399 on the SOM side of things, and the mezzanine board will allow us to sort of expand that by a lot. And hopefully by that time we get a few more 96 boards SOM with a variety of SoCs on it. And you'll see a bit more of this in the upcoming PX4 developer summit as well next week. I'll actually be talking with along with Keith from Upverter about how we actually decided to design this board and what was the process. So if you guys are free next week, you should join that as well. Apart from that, that's it. I'll leave the next 5 minutes for questions. If not, thank you so much for watching. You can always contact me at sahit.sarup@linaro.org. There you go. And ask about the project. Let's see. Where did you buy that double PCIe card? Okay, so right, that double PCI card has been, you won't get it. Like it's our thing. That double P. I hope you're talking about this baseboard where it has two PCIe slots. This was a request. So the vendor who built the baseboard, this was an earlier request by one of their customers to make it, and at that time they just had this board, so they sent it to me. The newer version of this board has a single longer 16x slot. Um, so you don't have to worry about weird PCIe things here. That's just for internal use. Margin. All right. Let's see if we have anything else. guess those were the questions. Again, you can reach me at sahaj.sarup@vinar.org. And thank you everyone for attending. Bye.